Hello there. My name is Zayneb Sadek, PhD student in Digital Research Center of Sfax. Today I present research theme entitled Clustering of High Frequency Oscillations HFO in Epilepsy using Pretrained Neural Networks under the direction of Mrs. Abir Hadriche and Mrs. Nawel Jmail. Our presentation follows the following plan. I start with an introduction, then I lay out the problem and the objective of follow thus. I define the databases used. We then present the clustering step using a deep cluster algorithm and our obtained results, and I end with a conclusion. Epilepsy is a neurological disease that is caused by abnormal electrical activity in the brain manifested by con- convulsive seizures. For this, physiopathological mechanisms of epilepsy are poorly understood, and despite any treatment available, about 30% of patients will still have recurrent seizures. For this, we have focused our work on drug resistant patients. Now we aim to present an example for a long-term recording for drug-resistant patient. So using epilepsy biomarker, the neurologist can detect the area responsible of epileptic discharge. For this, our objective is to work on a clustering algorithm for the separation of HFOs. Ripple R um, 80 Hertz 250 Hz and fast ripple FR 250 Hz to 500 Hz. Our goals is work on an IEG database to validate the approach for the detection and clustering of epileptic biomarkers. Test on a simulated basis. Label the performance. In this proposed work, we use the simulated data set is obtained by simulated data is obtained by a combination of a peak and HFO shapes as real EEG signal, sampled at to 500 and 12 Hz and of duration 2 seconds with 1024 samples. Thanks to different tests, we have prepared five classes of signals composed of spikes, HFO, ripple, fast ripple, and super pose, ripple, and spike. By varying different parameters, relative amplitudes, frequency of oscillations, signals of to noise ratio, SNRA, and overlap rate, we obtained 120 sets of simulated data composed of spikes and HFO events on this range 85, 105, 2000, 1315, 415, Earth ripples, and fast ripples. We depicted the three steps of the clustering pipeline. In the first step, we recovered the simulated IEG time signal, presenting a mix of pure HFO artifact spike and spiky event with the ripples. These events produce a complex shape in which it's difficult to distinguish the basic elements. In the second step, we represent the frequency of our studied events. In the last step, we used the clustering algorithm based on CNN for future extraction, as well as a PCA method and TSNE for dimension reduction. Then we applied the standard K-means clustering algorithm. The CNN is composed by convolution layer, clustering layer, fully connected layer, and classifier. Then the feature is extracted by the convolution layer in the CNN structure are called feature map. In this stage, we explore the clustering approach using spectral representation of IEEG in order to isolate ripples and other events such as spikes and contaminated noise. At each line, we find events in the frequency plan, as well as pure HFOs ripples in the frequency range 80 to 250 Hz. Fast ripples in 250 Hz to 450 Hz. Spike artifacts, high noise, and spike event with the ripple. This figure shows the spatial pattern of HFO distribution. These color maps represent a state dispute, spike, ripple, fast ripple, and artifact from 2D TSNA visualization after different feature extractor using ResNet 18. Therefore, it's expected that the future representation will be more compact and well separated as we progress through the used pipeline. Under here is the result of clustering algorithm. This figure represents the spatial distribution of simulated IEEG data after initial detection and final clustering using camis of certain CNN featured ResNet 18. Indeed, the clustering results presents five clusters where the upper lines is a frequency plan of artifact. The second line depicts a class of peaks and ripples. In the third line, there is a well ranked fast ripple class. Then, in the following line, we got a class of spike and mixture of spike and ripple. The bottom like presents perfectly the ripple cluster. The clustering results gives an accuracy of 94% for the artifact clustering is given. SE 98%, SP 95%, F score 97%. Or when we plotted a silhouette score shows the distribution of classes minus 1 means incorrect clustering and plus 1 means correct and very dense clustering. However, the two classes spike and spike ripple were further grouped into two categories where one of these groups was specially located in another far region. To conclude, investigate the HFO clustering approach to detect EIG events such as epileptic spikes, ripples, and fast ripples in intracranial EEG data sets, simulated IEEG. This network is created through a novel automated approach based on sequential feature extraction via pre-trained neural networks and TSNA methods for dimension reduction. Finally, the algorithm succeeded is relating a selection of events from five classes, namely spikes, ripples, and fast ripples, contaminated noises, as well as spikes with superimposed ripples. Thank you for your attention.